Now, another problem which is very important as well is in this kind of networks is the problem, we can understand it very easily, this is the problem of overfitting. There is a specific video on overfitting, but when overfitting occurs, what does that mean? That means you have too many parameters. If you have so many parameters, you have connections everywhere, parameters everywhere, that means that you overfit. You have a function that you have a h theta of x, which models everything, which overfits the data. That is well explained in another video. Therefore, we have to avoid overfitting. How is it possible to avoid overfitting? There are techniques for that. Techniques are named regularization. In statistics, it's named penalization as well. You can have L1, L2 penalizations, other types of penalization, a lot of possibilities for penalization, and I'm just going to give the idea and show one of these penalization here. I'm going to add to r theta lambda times a penalization first on the alpha. A penalization on the alpha and a penalization on the betas. Here I have a sum over m and L, let's say, of alpha ml. L, alpha ml, therefore L goes from 0 from 0 to p. L goes from 0 to p. Therefore here you have a double sum, a sum for m equals 1 to capital M, and a sum for L equals 0 to have alpha 0 up to p alpha mp in this case. Therefore, with that I have all the coefficients that are involved in my single layer perceptron, single hidden layer perceptron. And now I also have penalization on beta. Beta, it multiplies m, therefore you have for beta a sum over m of beta m square, and m here goes from 1 to m. Therefore here you have a sum over m of beta square m. This pink part is added to the initial minimization problem. What is the consequence of this? The consequence of this is that if you find, if the solution for one alpha or one beta is too large, is large, that leads to an increasing of this quantity. We have a lambda which is positive. And therefore, if that increases, if the global function at the end increases for given values, for some values of alpha and beta, you increase the minimization problem. And therefore the minimum is not this one. The minimum is not this value, that does not correspond to these values of alpha and beta. Therefore, this technique tries to find, it doesn't have the same minimum as the minimum you have without the pink part. And we can show very easily that, in fact, what it does, it tries to remove, to make coefficients closer and closer to 0. If you have some coefficients that are close to 0 here, that does not increase the global quantity. Here we have a lambda which is positive, we have some of quantities that are positive. If you want to have a minimum for these values, the idea is that these parameters are close to 0. Now, what is the value of lambda? Lambda is a positive value that we have to add inside the minimization problem, and lambda is most of the time chosen with cross-validation.